Good afternoon. Thank you for joining us again today for our self-build hour. We're really pleased to be joined once again by another self-build expert. Today we'll be speaking to David Gallagher from AC Structures. But just as a reminder about the format of today's session, we will be joined by David Gallagher to give a presentation on structures. During this presentation, you can feel free to use the Q&A button that's at the top of your screen in order to enter any questions that you have. If you don't happen to have that Q&A button, then you can enter it into the chat, but Q&A is better if you do have that. We will be recording this session so that those who aren't able to join us or those who would like to revisit the information again will be able to watch it on demand. You'll all receive an email when that has been posted to the website. So we're really pleased to have the number of people who have been joining us both live online as well as afterwards to watch the session on demand. There's been a huge uptake and we've gotten lots of really positive feedback from you. And just as a reminder, what we're trying to do here is get the main questions answered that self-builders continually ask us, and not only have us answer it, but be able to provide those answers to you directly from the professionals who answer these questions and deal with the concerns on a day-to-day basis. So without further ado, I'm going to introduce Dave. Dave Gallagher is of AC Structures. During his career, he's obtained lots of experience working in the UK and actually all over the world on really high-profile projects. He's then joined AC Structures as a technical director, and he's bringing with us his expertise on residential structural design, direct to the self-build client, but he also provides engineering services to several of the large construction kit manufacturers. So he's not only an expert on self-build structural design for clients, but also in modern methods of construction. So without further ado, I'll hand over the mic to Dave, and we look forward to seeing this come in.
Hello. Right, I'll start just by giving a bit of a background to Allen Caulfield Structures. So we were established in 2021 as a sister company to Allen Caulfield Architects. Allen was wanting a higher service from structural engineers and was really struggling to find the service that kind of matched what Allen Caulfield Architects was offering, so decided to set up their own company. So we've been set up to provide a full range of design services for custom build clients. So we're targeted at that. That is what we specialize in, and we also specialize in the modern methods of construction to facilitate that. So we do a lot of ICF projects, SIPs and timber frame, and we can offer a service right from the beginning of the project all the way through construction. And we can do, so there's a number of specialist items that we'll talk through later, like steel stair design, balustrade design, glazing design, and we can offer a full suite of additional services. In Scotland, we are SER certifiers and in-house, which helps speed up the certification process. It's essentially the role of building warrant. Okay, so just a wee summary of what we'll cover. So we'll have a look at the advantage of early structural design review, the important considerations when you're selecting your engineer, the different project stages, and when a project engineer, the advantages of having the project engineer and your modern method of construction engineer as the same person. The role of the structural engineer throughout, And then at ACS, we split our stages to match the architectural rebus stages, and we'll just go through a bit of that, a bit of what the traditional role of the engineer is, and the kind of extra offerings that that we offer and that you should be looking for from any structural engineer that you appoint. We'll touch on the site investigation considerations. It's often a big unknown for clients, and we'll talk through that. Things to consider if you're at a point where you're still looking for a plot, or if you're at the design stage, things to look out for that will help keep your structure as efficient as possible. And then we'll just touch on how to understand what the site investigation comes out. These documents can be over 100 pages of quite detailed information. So just how to navigate that. And then we'll summarize that with some plot considerations. And then stage 2 is one of these other stages where it's a scheme design. So we'll talk a bit about that. And then the role of value engineering and what that is, and how from getting an engineer appointed early in the process, we can maximize value engineering opportunities without compromising the output of your design. And then I'll just finish up by comparing the methods of construction that are available, and just touch on the pros and cons of each one, because they are more appropriate to some applications than others. And then just very briefly, I'll touch on the detailed design, the output that you will be getting from a structural engineer on your project. Okay, so to start with then, early structural design review, we would recommend clients get the engineer involved at the early planning stage, where you might have an idea at this point of the general form of the structure, but there's still time to incorporate efficiency within the design. Layouts aren't quite set, and window locations are still subject to a bit of development. So this will help us identify locations that could quite drastically reduce the cost of your structure, and we'll touch on that a bit more later on. So your structural engineer will provide a different perspective. We're looking at it from a much more practical view, and we have buildability at our heart. So we'll be looking at it as the first representative of your contractor. We'll look at things that might impact your planning application. We'll check that the structural zone allowances that have been made are sufficient. If you get too far down the line and your structural engineer comes back and asks for extra depth, and you've already got a planning permission with a confirmed maximum height of your roof, you're then either going to have to go back to planning or compromise on your floor to ceiling spaces. The transfer structure and column locations, minimizing the amount of structure will always give you the most efficient, and that the way to do that is to simplify the way that the load comes down from the roof all the way through the building, and we'll touch on that in more detail later as well. And as I said before, we'll look at the value engineering opportunities on your project. We'll give you advice, and we'll talk you through the pros and cons of that. Sometimes the client will want the feature, or there will be a demand, and all we are doing is helping to inform that decision process. You're going into that decision with your eyes open. So just a couple of things to consider when selecting your engineer is to make sure that the level of input offered by the structural engineer is the same. Like anything, it can vary quite a lot. At ACS, we'll offer a service, and clients can choose how much of the scope they want to appoint ACS for. We break it down into different stages, and by committing to one stage, you're not necessarily committing to the others. It's all stage by stage. So it's important that that is the same. Other things that can be excluded are things like connection design and bar bending schedules, things like that that can have a bit of extra cost and can skew the comparison. So that's so the level of input's kind of touched on that as well. On-site support. So at ACS, we'll offer a site visit at the beginning of the project. We'd like to go in at the site investigation stage and go and see the site. If you've got an existing structure, we would like to do a survey and have a look at that. Even if it's a building that's coming down, it can tell us a lot about how your plot is behaving, and if there's any signs of defect that could raise alarm for the scope of the site investigation. Make sure that your engineer has a relevant experience in the method of construction. Particularly if you're looking at SIPs or ICF, these are quite particular methods of construction that have specific detail requirements and coordination considerations that your engineer needs to be aware of. Don't let your project be the one that your engineer uses to learn about the method of construction. We've got a vast amount of experience in-house, and we rely on all the previous projects, and you're getting the benefit of that on yours. The relationship with your architect is quite important. If that the engineer and the architect being on the same page and collaborating together throughout your project, it is going to be vital for your project to be successful. They need to be able to talk to each other regularly, and keep that communication going all the way from the beginning to the end. Have they got previous projects with your specialist manufacturer? So this is the next level beyond the kind of having experience with the method of construction, but also do they know the specific requirements of the manufacturer that you're looking at? And they'll have their own requirements and details and specifications. They might have stock sizes, for example, that they like to use, and it speeds up the whole process if your engineer is aware of that. Passive house detailing experience. Now, this is becoming more and more important as the thermal requirements of buildings are getting more into the kind of the front thinking of clients. And ACS, we have a lot of experience working closely with ACA and making sure that our details are passive house compliant or comparable. And just be aware of false economy. The structural engineering fee represents the time that engineering company have allocated to your project. All engineers will be working on a similar hourly rate, so it is directly equatable to the amount of time. So advantages of the project engineer being your specialist engineer. If you're going for the early involvement of your engineer particularly, this allows the same engineer on your project from the beginning, and they'll know the superstructure requirements. You don't have that break in communication as the project goes along. So you basically got your specialist engineer right at the beginning of your project. Any design assumptions that are made at the early stages are more likely to be adopted throughout your project because it's the same person. You're not introducing someone halfway through that has their own ideas. The preliminary costing is more accurate because of the previous points, because it's more likely to reflect your final solution. It allows you to get some costing information earlier on in the process. And similarly for the loading, for the foundation design, that there's not that lag in getting loading information from the specialist engineer, which would hold up the foundation design. So all that can be confirmed right at the beginning, and you can start processing the foundation review much earlier on. And as I touched on before, like the preferred detailing and specifications, they're all known, so they can be incorporated into the structural drawings before you've appointed your contractor. So you might already have a price agreed. You might know you're definitely going with them, but you might not be ready to press the button but that your engineer can advance the design in advance of that. And early coordination. So knowing what the end solution will be allows us to coordinate with the architects, identify service zones and load paths, that kind of thing, that just help the architect finalize and progress their own drawing pack as well. It also streamlines the design process. So if your specialist engineer is different to your project engineer, which is quite an often thing, and we do it as well, is your specialist engineer calculations will need to go to your project engineer, and they'll be approving that and checking that it all reflects their assumptions and recommendations. So there is a natural kind of back and forth there that needs to be accommodated in the program. Okay, so I'll have a look now at the project stages that I've mentioned at the beginning. So this is the traditional stages of a structural engineer. So they'd come in normally at building warrant. Sometimes they come in after the submission of their architectural submission of building warrant, and they'll progress their calculations and drawings to reflect what's been drawn. So traditionally, they would actually just try and just make what the architects work show and work, which can be much more costly. And if they can't get it to work, there's a lot more back and forth and potentially having to go back to planning or building warrant with amendments. And then you get your production drawings and your output from that then goes through to third-party designers. And these are people like your stair designer, if you've got a steel staircase, balustrades, large glazing panels, that kind of thing. So at ACS, we've broken it down and introduced additional stages. So we come in initial design, and we'll have a look at your plot. We'll do a preliminary desktop evaluation, and we'll off the site, and we'll specify the site investigation, and we'll go out to different geotechnical engineers. We'll get tenders on your behalf. We'll review them for you, and then we go back to them with any comments. We compare them, and then when they're ready to do the phase one report, which is I'll go into more detail later. The planning application is where we'll do the stage 2 design. So this is our scheme design. So we'll look at the architectural drawings as they are. Ideally, this is, like I said before, like an early stage planning where you've got a good idea of what you want to do. We can have a look at different layouts and advise of which one is more cost effective. We can have a look at different construction methods and decide and help you decide which one if you're in between options. And then after the production drawings, we'll also have an additional stage where we can come on site, and we're aware that self-builders need or expect a lot more input after the fact to help them through the process of understanding the requirements of site and interpreting the drawings. So this isn't an allowance that a general structural engineer that's not experienced in self-build will have allowed for. They'll send out their drawings, and then that is them finished. Will help identify the site-specific hazards to meet CDM requirements if you're taking on that role, or if it's somebody else, we'll make sure that those are clearly stated on the drawings. Okay, so I'll just go through a bit more detail of the stages that I've talked about. So the stage 1, this is the preliminary desktop evaluation. And there's an example here on the slide in the bottom left of what we will do. So we'll have a look at your plot identify any kind of specific hazards, and that will inform what we send out to geotechnical engineers. We'll then review that, as I said, and we'll have a look at that. And a lot of time the scope can vary quite a bit, so we'll just guide you through that process. And then once we've been to site and they've done their investigation, they'll send out a report, and we'll review that, and again relay that back to you and explain what the effects are on the foundation design. and there'll be an overmark that highlights that, and we'll confirm, if it's going to be normal strip foundation, which is the cheapest, or if it's trench fill because you've got poor ground at high level, or if indeed it needs to go to piles, what the implications are and what additional investigation, if any, is required. Okay, so important site investigation considerations. Your site conditions are the biggest unknown on your project. It's the only thing you can't control once you have the plot. The scope of the site investigation can vary quite considerably depending on the risks identified for your plot. And it can vary quite close. So if you've got a neighbour down the road, it doesn't mean necessarily that your scope is going to be the same. The tender process of just the actual fact of going out to different consultants, you get a lot of information from that without any commitment. We have people that we go to all the time, and they're happy to give advice on what they think the scope will be of the different stages, and they'll identify any risks or any knowledge that they have of that area. You'll get that from them, so that even if you're not thinking of doing it for another month or two, going out now will give you a big heads up of what might be waiting for you down the road. So it identifies the appropriate, efficient, and buildable solution. So it's going to tell you exactly what you need to do to make your project, to make your structure safe and suitable for the ground conditions. So you're going to need to do that regardless. So the earlier that you find that out, the easier it's going to be for you to budget and make sure that the site's suitable for what you're intending to do to it. The outcome of the SI can vary significantly. What your foundation costs are can be double from a strip footing to piles, and the timescales can be much more. There's enabling works and things that can actually cost just as much as the foundation, and it allows you to reassess or confirm the budget that you've allowed is still applicable. So piled foundations, we will always avoid those. They're only ever used when they're absolutely necessary, and they do have cost and time implications. Sometimes they can be £1,000 a pile, so it does stack up quite quickly. And the SI, the site investigation, will also give you a conceptual site model, lab testing and monitoring. It will look at the chemical makeup and contamination of your site. It will make sure that it will identify any protection measures that you might need to keep operatives safe during the construction process, and any additional measures you might need to take to protect water courses and things like that. So just a brief breakdown of understanding the site investigation. So it's split into geotechnical and geo-environmental. So the geotechnical ultimately looks at the physical properties and understands what's underneath the ground at a shallow, between the ground level and the rock. If you're going down to the rock for piles, whatever, it will go down that far as well. But typically, if it's a trial pits will normally go to about 3 meters. Boreholes, if we're just looking at clay sites, will generally go to 6 to 8 meters. And if we're anticipating piles, you'll do 4 or 5 at about 12 meters, and you do one larger one to about 20 meters, just to make sure there's enough information there for your piling contractor. Geo-environmental looks at the specific contamination issues and things like the history of the site. There's you get a conceptual site model, lab testing and monitoring, chemical and gaseous contamination, identification of protection measures. So this, if we need to go to that level, you're talking about ongoing monitoring, them needing to come back over possibly a 3 to 6 month process to rule out any gas protection or to confirm the specification requirements when it is required. So the phase 1 desktop evaluation, which I touched on before, it looks at the history of the site, the potential risks, and establishes the scope for the phase 2, which is your intrusive investigation. And the phase 2 is your trial pits and your boreholes and your monitoring. And then you, at the end of the phase 2, you'll get a report from your geotechnical engineer with the recommendations specific to your site. And if you're needing percolation testing for your drainage, this can also be incorporated within that report. Plot considerations then, just on now we've kind of gone through the site investigation requirements. When you're the first 5 here are things that you can look at when you're looking at a plot. You can see these things for yourself either by looking at the plot or by a bit of research. So the previous use of the plot, if it's greenfield site, then perfect. You can stop there. If it's a brownfield site, what was on there? So a brownfield can be, it doesn't necessarily mean there was a building there. It could be something as simple as having services running through it. If there's existing structures, is there a risk of asbestos contamination within the structure? Is there evidence of previous movement? If there's any signs of made ground or history of made ground, that can be a red flag as well. That can be contamination. It can be quite expensive to remove, and you generally want to have it removed throughout any garden areas to 600 millimeters below the finished ground level, and in its entirety around the building plot. The proximity of adjacent structures. If you have neighbouring buildings on the boundary of your plot, you might have party wall issues where you need to prove that you're not undermining that structure. If you've got structures on your plot that are yours, then you still might have to, and they're to be retained, you still might need to underpin those, which it adds an extra level of complexity to the foundation works. And existing services, looking at utility records, is there shared services running through your site? Depending on what they are, they might have access requirements, they might have areas where you're not allowed to go within them. Some of them can be between 1 to 3 meters, so it can create an exclusion zone right through your plot. Then for any site, so the next 4 are for green and brownfield sites. If it's a sloping site, just be aware that that does bring some considerations when you're looking at the design. It's increasing the likelihood that you're going to have some retention. It might have access issues, and you might need to consider slope stability depending on the size of the structure and the nature of the slope. Trees, if you've got mature trees on the site, or if it's a clay site, but you won't know that till later on, and I'll touch on that later. You'll need root protection, and there's the added risk that you're going to have heave protection later. I talked about accessibility, but you're thinking about access for vehicles. Is it restricted all the way up to your property? Are you going to get the lorries, if you're thinking about doing off-site manufacturing, are they able to bring their lorries to your site? And any water sources nearby can have implications on your any contaminants and the processes, how your contractor will approach the construction. So things that you won't know from looking at the site, but there are websites available for doing your own research in advance. If you're looking at a plot that you're thinking of purchasing, there's online resources for each of these. So risk of flooding, obviously you've got 2 considerations here. You've got during construction, dewatering is can be quite an extensive process, which makes it expensive and adds a level of safety consideration to it. There's a risk of contamination, and it can have program implications. If there is a if your plot is within a coal report area, I would encourage you to look into that. At the beginning, you can get coal reports online, which will identify whether there's been any issues in that area and what additional measures need to take place. Similarly, radon, you can find out in your area if it's a radon report area, affected area, sorry, and you may need to arrange for monitoring, which will identify any protection measures you might require. And unexploded ordnance. I've not yet worked on a plot where this has been affected, but I know there's plenty of locations, and obviously that isn't a cheap exercise if that's found. And you'll have if you're in an area, you have a safety health and safety obligation to identify that. Okay, so then the next things are things that are only going to come out really from the site investigation. So variable ground conditions can impact your foundations if it's sitting on good ground in one corner and bad ground in the other. The risk that your building will settle differently needs to be engineered out by your structural engineer. High water table. So this is different to the risk of flooding. This could be a high water table could be 0.5 meter underneath the ground. So when you're excavating for your foundations, your trenches can be collapsing in, and again you'd need to dewater, but you might not necessarily know that until after the site investigation. Poor ground to depth. If you've got poor ground greater than kind of 2.5 meters, then that's when you start having to consider a piled solution as an option. It's kind of the limit of the trench fill, which when I say trench fill, that's just a trench in the ground that you fill with concrete down to the suitable bearing strata. Clay and mature trees can be a big one. If you're in an area of clay and you do have mature trees, the zone of influence of them is likely to encapsulate your whole site, and that can push your foundations down in worst case scenarios to 2.5 meters, and sometimes will push you down the route of piles as well. Local sources of contamination. This will get picked up in your phase 1 report, where they look for things nearby. It could be a landfill, there could be natural resource sources as well. And then the last one is the basement retaining walls, things you can control as you develop your design, which will add additional cost, and not just with the additional foundation works and enabling works, but also things like tanking and getting the specialist advice. Adds going into the ground is much more expensive than adding an additional story above. Okay, so I'll just quickly go through the early stage design. So this is just an example of what we do a bit at the kind of planning stage. We'll look through your scheme, identify where the structure needs to be, and there's a lot of back and forth with the architect at this point. And like I said before, we will review the construction methods and identify which one we think is the most suitable. We work with ICF, SIPs, and timber, so we're not biased in that. We have contacts and close relationships with all three, so we can give you unbiased advice. And that just gets you through to a point. So at the end of the planning, you've got a scheme design that gives you a bit of confidence that what you're submitting to planning has been looked at by a structural engineer and is structurally viable. Okay, value engineering from the beginning. So these are kind of recommendations when you're thinking and developing your own scheme. To work with your site constraints, try and work with levels as much as possible to avoid retention, and stay away from boundaries and trees where you can. It's not always possible, but those are the kind of things that you should be trying to consider right from the beginning. Transferring gravity loading from roof to foundations, just keeping it as simple as possible, having walls aligned between first and ground floor, that kind of thing just makes a big difference for the complexity and the cost of the structure. Considering the stability of the structure, so when you have a lot of open plan areas, this makes the structure less efficient. You generally need to provide steel to provide the stability that the walls would have provided your building. Avoid large structural spans above critical elements. So this is things like if you've got a large open space for bifold doors, for example, if you're then putting a big steel beam above that and it's maybe taking another beam in another direction, you then got a large beam above it, above glass, where the deflection limits for that beam are going to be really onerous, and the sizes ultimately are kept to a minimum to maximize the height of the glazing. So you're getting conflicting requirements there. So avoiding that from the beginning is something that we would be looking at and advising. The bigger the structure zone that you can allow within your floor, the more efficient your structure will be. As you minimize the structure, the weight of the steel gets heavier and the cost goes up because the structure is acting less efficiently. And simplify the roof structure where possible. Think about how if you've got that are coming in perpendicular to each other, how are they interacting? Where's the support coming from? And yeah, simplifying detailing and avoiding cold bridging. So as we try and avoid cold bridging, there's a lot of input there with the architect, a lot more coordination, and generally you're providing thermal breaks, which also come at a cost. So this is just an example here of a typical project that we have that shows the measures that we've had to go to bring the loading down. So you see there that you've got your load bearing walls. If you can see my cursor here, there, that need to be taken down to ground. Now, if that doesn't come to ground, then you're creating the steel structure in here, and you've got another load-bearing wall in here for the other one. So you're then transferring loads out. So if there's a wall there, it would all disappear. So you've created 3 columns and 2 beams just to get that load down to the ground. So this is just a very generic kind of bending moment diagram, just showing how that load is coming down. And this structure, this section here is through here. So so you can see there that it's because the load path is having to go down and then across. It's adding a much more additional time and cost to the contractor. It might restrict which contractors are willing to have a look at your project as the structure becomes more complex. Okay, so just comparing methods of construction. I won't go to too much detail this time, but timber frame, you've got the speed of construction, particularly if it's developed as a panel system. There's obviously sustainability advantages to it, and it's got low embodied carbon. SIPs industry, again, it's similar. The speed of construction can be 5 to 7 days on site. It's a high performing. It's got good air tightness, and again, it comes with a low embodied carbon. Not as good as timber, but better than that ICF construction. ICF has got, it really comes into its own if you've got a raft foundation, or if you've got retaining walls, because you can create a monolithic structure that helps create a tanked solution, and you can keep the same construction throughout your project, and it's got the best air tightness of the 3. Okay, detailed design. This is just an example of some of the outputs. So at detailed design, we'll be looking at the developing what we did at stage 2, doing supporting calculations that will be submitted along with your drawings, and finalising structural sizes. And then they will get submitted, either self-certified in Scotland or submitted along with the drawings in England. Okay, that's me. I'll pass you back to Jenny and see if you've got any questions.
Thank you very much, Dave. That was a very high-level overview, but I think it gives everyone an idea of how much goes into the structural design, and how, in an ideal world, the structural design and the architectural design would work hand in hand in order to get you sort of the best outcome, both in terms of design and efficiency, and also that efficiency related back to cost. So I will let Alan go ahead and field some questions to you.
Afternoon all. So if anyone, just to recap, if anybody does have any questions, can you put them into the Q&A or the chat whilst we've got sort of 10 minutes more time with David before we wrap up. So I think just one thing, just David, what's the biggest mistakes people make, whether it's in the design of their houses or so do it as two-part. What's the biggest mistakes people make in designs early on that could be avoided from a structural engineering point of view, not from an architectural point of view, obviously. And then the follow-up from that is, well, how do we try and resolve those, or how do we try and get ahead of those problems?
Okay, yeah, I think the biggest mistake is introducing engineering complexity to your design, requiring a steel frame and not necessarily knowing that you've done it. Not aligning walls. Sometimes we'll get a project where the walls are only 400 millimeters away from each other, and you still need the same beam because you're not going to get it across. Or by moving a door opening slightly, you can have a column that comes all the way to the ground instead of a transfer frame. So it's things like that. They're the big ones, and that's, if you get an engineer at the beginning of your project, those are the kind of things you can avoid. And then the other one is underestimating the importance of the site investigation. I regularly have to explain and fight the case of a site investigation, but it's really important. It is the only thing that you don't really know about your site, and we can put you in touch with experts that will give you the best advice. No one's trying to convince you to put piles in that you don't need. It's everyone's trying to be as pragmatic as possible.
Yeah, and I think that the follow up to that, the SI is so important, and we always try and get clients before they've purchased a site to do it. And some people will think, well, I'm not spending £400 or £500 on an engineer or a digger, or a couple of £1,000 on a full SI before I buy the site. But we would usually always push back and say, well, you might be spending £150,000 or £500,000 on this piece of land.
Yeah.
Spend the little bit of money, maybe negotiate with the landowner that the cost of those expenses come off the purchase price as an abnormal. But I think, as you said, it's just fundamental to the budget and to the buildability of the project.
Yeah, and as I said in the talk, even going out to them, you'll get a lot of information from that, and the site investigation split into the phase 1 and the phase 2, so you can instruct the phase 1 and do the phase 2 after you buy the plot. You'll get a lot of information from phase 1. You'll understand the recommendations of the site investigation. So if it was only trial pits, you're talking a couple of £1,000. If you're talking boreholes, you can be up to £10,000-12,000. So you'll want to know that before you make the purchase, if possible.
Yeah, definitely. I think the other thing is what's you obviously work. We've got a unique relationship at ACA and ACS where we work hand in hand. What have you? It'd be interesting to know what you've learned as an engineer from working with us. Challenging design types.
Well, I think communication is key.
Yeah.
I think all the engineers that work for ACS have really got an appreciation for how important that is. and we take that into our relationship with external architects as well when we approach that, and that's why we've actually done so well with external architects, because it's not the engineering way. Engineers typically like to be left in a corner with half a light on and just be left to do their calculations. So we've managed to find the 5 that don't mind talking to people, and yeah, it's worked. It's been working really well. So yeah, I would say it's all about communication and understanding where each other are coming from. And I think ACA have also, they've had that. Having an engineer in house has done the same for ACA. They preempt the structural requirements now, even though some of them don't want to.
Yeah, and not try and stifle the design process, but make it more efficient. I think you touched on the passive house element and the detailing of that. That's really interesting that it's something it's not just architecture or passive house experts, it's structural engineers that are now becoming more aware of that, and you guys have had to be aware of that. And what's the sort of things that you're coming up against or trying to have to detail out, or work that maybe normal engineers might not be aware of?
It's cantilevers generally are one of the big challenges, and where ridge beams continue out. If you're trying to create a nice overhanging canopy, sometimes the ridge beam heights can be different, because you're trying to you don't have the same thermal requirements in the canopy, and you want to push it up to maximize the architectural qualities of it, which means that the beam is no longer continuous. So that's always an interesting one, and yeah, there's always a conversation to be had there, but it's getting that continuation into the building, because a lot of the time structural engineers want to break through that naturally. That's what the structure wants to do, and the more your engineer understands what the limitations are, the less of that kind of going around in circles to come up with the final answer you'll need to do. So as bespoke as each of our projects are, it's generally the same solutions for these things. It's just adapting them in a different way, but the general principles have already been agreed between ACA and ACS, so we know what the solution is. We just have to adapt it.
That's good. Yeah, and I think the one thing that we are very aware of is that we've got lots of wow features in our clients' self-builds, and that's the joy and the fun, and it's knowing where you spend the money on the right features rather than wasting money. And I think that's the one thing we found from the sort of early stage feasibility exercise is knowing where there's going to be portal frames or round gable windows or whatever it might be. That's really important, because it's fine spending £10,000 or £15,000 on a feature if that's what you want to do, but you don't want to waste £10,000 or £15,000 on hidden steelwork to try and do something that solve something that doesn't align, or a poorly fitting stair landing, or things like these that we see over and over.
Yeah, totally agree. Yeah, and things like the glazed gable, if there's enough space for the structure, then that simplifies it. But sometimes the clients are looking for the glazing to be right up to the underside of the canopy, but actually that has a structural implication. So it's identifying these things right at the beginning, and just because a lot of clients don't actually need the glazing to go to the top. It's a nice to have, and if it's going to have a significant cost to it, it's something that quite quickly they can take out if they understand.
Yeah, definitely. I suppose it's been aware of all these things up front, and then making a conscious decision about the design choices early on. Jenny, is there any questions that you've got? Anything that you want to ask David while we've got on before we wrap up?
Yeah, well, we've got a new question that just popped in that asked, who do I go to investigate my site? Got an existing stone-built basic single-story house, and they want to see if the barn is suitable to be retained, because that's what the planning authority wanted to do, and if so, how can it be extended? So sort of it's a multi-pronged question that's talking about not only the site, but also the existing building within the site,
Okay.
and how you get the assistance.
Yep. So, I mean, ACS, your structural engineer, will be able to go and assess your existing structure. We would try and tie that in with the site investigation, so we're doing both at the same time. So it's one visit to just maximize efficiency. Your structural engineer can guide you through the site investigation requirements. So that's part of our stage one. So we will have a look at the risks as we see them, and we actually do quite a bit of that in the fee proposal. So we, in your fee proposal from us, we'll have identified whether we think radon, coal, flooding is an issue, and then we'll go out to the site investigation consultants, and like I said, in stage one, we like to be there on site as they're doing it, so we can see it firsthand as well. And it means that as they're developing their report, we already have a good idea and can keep the design moving on in the meantime.
Yeah.
Is that,
I think
did I answer that,
one,
or just go off on a tangent?
No, I think just, yeah, and I think just I would push back, Don, on whether you want to keep it or whether it's practicable to keep it. And I think if you're doing major renovations to a project where you keep one wall or you're constrained by that, I would really be pushing back on planning to see if it'll certainly be more cost effective to demolish and start afresh. And again, you've potentially got the VAT saving. But some planning local authorities won't allow you to, but most will need justification. So that might be a structural report to say that it's not suitable for retention, or a financial quantity surveyor breakdown to say that it's not financially viable to retain and make good. So, but yeah, I suppose I would start with, what do you want? Do you want to retain it and then build up, or do you want to demolish to start again, and then make your case and your argument around that?
Yeah, and we can provide our report to back up the case you're trying to make within obviously the structural license, but yeah, we can help you with that too.
I think, Jenny, I think that's us got through all the questions that have come in. So
yeah, that was fantastic. Thank you very much, Dave, for your time today, and for sort of enlightening everyone on the role of a structural engineer, and how we can get that benefit sooner rather than later. I'm just going to go over some top takeaways that I jotted down during your talk. A few things that our early structural design review really provides important insights into buildability and efficiency of design. You should always select a structural engineer who has experience with the specific requirements of your project. So try to be really specific about what you're trying to get out of your project, and what aspirations you have when you're talking to potential structural engineers. A structural engineer can offer insights into the suitability of your plot for development. A site investigation will uncover many of the unknowns that have potentially large impact on groundwork, sound foundation, and these end up being a large part of your budget. So you want to uncover those as soon as possible. And finally, your structural design really can affect your energy efficiency. So your structural engineer can hopefully have those conversations with you as well. I just want to let everyone know that next month we'll be doing this again, same time, second Thursday of the month at 1 o'clock. We will be joined by Julia Kendall to talk about interior design. We appreciate your time during the last hour and your attention to Dave's talk. We will email you all when it's ready to be uploaded, so you'll be able to watch that on demand if you still have questions. And as always, please feel free to reach out to any of us, either ACA or ACS, if you have any specific questions about the presentations today or about your project, and we'll be happy to help. Thank you, and we'll see you again next month.